talked about kinematics, which is how things move. For exam 2, we talked about dynamics, which is why things move. In particular, we had to bring in the concept of force to tell us why things are moving the way that they were. And now for exam 3, we're going to talk about conservation. This is another way to examine both the how and the why of motion. And in particular, you're going to be able to resolve the same types of problems that you already saw from exam 1 and exam 2 using a completely different framework, and where you can use the laws of conservation from physics. Now, it's weird. How come we can do physics in 2 different ways? Well, I always tell you you can solve problems in a lot of different ways. And in the 1600s, there were a bunch of different people who were trying to solve these kinds of questions, understanding how and why things move. In particular, there was a group of physicists, philosophers, engineers. They were basically all the same thing at the same time, and they felt like there should be some kind of conserved quantities, that somehow some things could neither be created nor destroyed. Leibniz was one of these people, and I'm showing you a picture of him here because he has funny hair. So we can discuss this idea of conservation in the terms of both energy, in particular the total energy, and momentum in the class. Today we're going to talk about energy conservation and how energy can change from one form of energy to another form of energy. Later in the class we'll also use these concepts to talk about thermodynamics, which is kind of a foray into chemistry, and you've probably seen a lot of these concepts in chemistry class. And in fact, chemistry is one of the places where we think about energy the most often. So what kinds of forms of energy do you think of, or what do you think of when you think about energy? Sometimes I think about light, the light in your house. I mean, I know that light bulbs use energy. You can think about heat. Obviously, your heating kind of apparatus in your house, you're using energy. Maybe you're bringing in some kind of heating fuel. That makes me also think of my car, which I didn't write down. There's actually such a thing as an elastic or spring energy. We're going to talk about that towards the end of the class for exam 4. Solar energy, nuclear energy, and wind energy are all types of energy that people talk about, in particular renewable energy sources. And then, of course, if these 3 different things, solar, nuclear, and wind, they give us electricity in our house, so that must be some kind of energy too, or at least have something to do with it. We can think about how these things are possibly related to each other, how they're similar, and how they're different. In particular, let's think about a wind turbine. It takes the energy from the wind to rotate the turbine, which rotates a turbine that makes electricity, and then that electricity is transported to your house so that you can turn on the light switch and the light comes on. When the light bulb is on too long, it feels warm and it kind of makes heat. And so we can combine a lot of these different things together, and what we realize is that there's different ways to have energy, and they can change from one form to another. So let's define energy. Energy is the capacity to do work. So this is the physics definition, and we have to think about, what does that mean? What is work? So we can define work. Work is the energy that's used by a force to move an object. So we can think again about that wind turbine that we just discussed. The wind pushes on the turbine. The turbine rotates. We learned earlier that when you rotate an object, you're creating a torque on it. When you create a torque, then it's actually equal to the force that's created times the perpendicular distance from the rotation point, right? R times F. And so that must mean there is a force in order to create that torque. And so the work that means that the wind is doing work on the turbine in order to rotate the blades. And this work is a form of energy. It's converting the wind power into the rotational motion of the turbine, which means that it's making it move. And that means that it's a type of energy. And I want to be very clear that work is only a form of energy in that it's using up energy or turning one type of energy into another. So some of the types of energies that we're going to talk about are somehow a capacity or somehow a motion that is an energy, but work is one of these things where you're changing from one type of energy into another. During this class, we're going to mathematically define both energy and work, but today we're actually mostly going to talk about it in a conceptual way. So let's talk about a little analogy. We're going to talk about energy as some kind of natural money. So let's talk about real money. You have an account. In your account, you have maybe checks, and maybe your grandma bought you some bonds. The checks are something that you can, write a check, or you can get cash out of your checking account. So it's very liquid. The bonds are something that's, more savings type, and you can't really turn them into cash very easily. So you've got these two different kinds of things in your account. You can receive income from the outside, and you can spend your money. So the income comes in, and that changes the amount of both liquid and possibly savings that you have. And then you can use this money in order to buy things or pay your rent or pay for your tuition for this wonderful school that you're attending. A normal account is an open system, and what I mean by that is it's able to interact with the outside world. In this case, through getting an income and paying out expenditures. We can also define this concept of wealth. Wealth is like the energy of the system, or the money, the amount of money you have, but we'll call it wealth. And the change in the wealth that you have is equal to the amount of income you have coming in minus the amount of expenditures you have going out. So again, this is not the total amount of wealth that you have, not the total amount of energy. It's the change in wealth that you have. And so this is kind of like you're changing one type of thing into another, one type of expenditure or wealth into another, income and expenditures. The inside of your account is a closed system. So for instance, if you bought more bonds with your checking account, then you would be turning the liquid money that you have into savings. Vice versa, you could cash out some of your bonds and turn them back into money. And when you do this, you're acting just inside the closed system, which is your account. And when you do that, you're not interacting with the outside world at all. So the I is constant, the E is constant, and so when you trade money from checking to bonds, delta wealth does not change. There is no change in wealth. So with this example, we've kind of shown that you can have a system of money, and this system in this case is your account, and it's the thing that we're interested in. Likewise, in physics, when we talk about a system, we can have some kind of system in which energy can be transferred on the inside, and it can talk to the environment as well. So when energy is transferred from the environment to the system, then you can have work done on the system, and in this case, your energy can increase, or in this case of your account, then your wealth can increase. When energy is transferred from the system to the environment, it's like the expenditures from your bank account. So you're losing energy from the system. And energy can be transformed within the system, just like in your bank account, where you can change it from your checking into your bonds. You can change between lots of different kinds of energies that exist within the system. The environment is the stuff that we do not directly care about in the system. It's not inside the system that we're actually thinking about, but it does interact with the system. And so in the sense that it will absorb heat, or it can do work on the system, which can change the energy of the system. And this is the same way that your income and your expenditures are interacting with the environment. If a system is isolated, it's a closed system. It does not have any or no appreciable amount of interaction with the environment. And this would be like if you had a big bank account, but it just sat there switching between bonds, and you never spent any of the money, and you never got any income from anything as well. So if a system is isolated, we can cross out these arrows of interactions with the outside world. Interestingly, if a system is closed, just like in the bank account where the wealth didn't change, the energy of the system also doesn't change, at least the total energy. So the change in total energy of the whole system is 0.